Hello everybody, welcome back. Today we're going to be starting 4.3 mixed and entire radicals. Today's lesson is going to focus on expressing an entire radical as a mixed and vice versa. So let's look at some, let's make connections. You guys remember when we had equivalent fractions? So we can name the fraction 3/12ths in many different ways. It could be 1/4, 1/4, 5/20ths, 300 1/20ths, or 100 400ths. So how do you show that each fraction is equivalent to that? So why is that in the simplest form, right? So what we do is we multiply the numerator, or divide the numerator and denominator by 3 to get the equivalent. So same with those fractions, we have what's called an equivalent expression for any number that has the same value. So if you look at this, if we have the square root of 16 times 9, that's equivalent to the square root of 16 times the square root of 9. Because if you multiply them, you would have 16 times 9 is 144. The square root of 144 is 12. And also, if you had the square root of 16 multiplied by the square root of 9, that would be the square root of 16, which is 4, multiplied by the square root of 9, which is 3, which indeed is also 12. So similarly, we have the cube root of 8 times 27. We know that is equivalent to the cube root of 8 multiplied by the cube root of 7, because the cube root of 8 times 27 is actually this equivalent to the cube root of 216, which indeed is 6, and the cube root of 8, as we know, is 2. The cube root of 27, as we know, is 3, and 2 times 3 is 6. So this is going to help us get an idea of how to write a mixed radical as an entire radical and vice versa. All right. So remember, we got to remember some of those multiplication properties, right? So if you have the two numbers multiplied together, they can be split up into 2. So what you want to do when you're finding these is you want to look at the square root of 80 and you want to determine what is the greatest perfect square that is within 80. That's what you want to identify. Okay? There's a couple of ways to do this. So what I'm going to do is I'm going to show something that we learned in chapter 3 when we looked at prime factorization. So one way to do it is to look at prime factors. Okay? Or you can do what I said before, just look for the greatest factor that's a perfect square. Either way will work, and I will show you both. So one way to do it, like I said, is prime factorization. I'll show you that method, and then I'll show you a way that I like better. But again, I'll show you both ways, two methods. So to simply factor the two quick factors, that would be 8 and 10, right? And that would equal 2 times 2 times 2, and then the 10 would be broken up into 2 times 5. So we can list it as the this should still be under a radical. My apologies. So I'll fix that. I didn't mean for the radical to disappear on me. Okay. Same with this. This also should be written underneath as a radical. There we go. That's better. There we go. Okay. So you may recall that when we looked for a perfect square, we had to have some groups. So you'll notice there's two groups of 2. The 5 we're going to have to leave underneath the radical. That's the whole idea. Again, this is not my preference on how to do this, but I will show you how to do it once, and you can continue to do it with the prime factorizations. But then I'll show you my method that I like. Okay. This would be grouped as. So I'll rewrite this line as group there because it's perfect square, so we're going to group it in pairs, as you may recall. All right. So then we can split these radicals up. Okay. So that's gone, and that's going to be multiplied by this. Oh. So we split it and then multiply by the square root of 5. So we can break it down, right? So here we have the square root of 2 times 2, which we know is simply 2, and then that would be multiplied by, because square root 2 times 2 is 4, right? So the square root of 4 would be 2, multiplied by 2, and then there's nothing you can do with the square root of 5, and you leave it, and then you simplify it by multiplying the 2's together, and you get 4 root 5. Okay, that's the one of the methods they show. I find that a little more time consuming and takes a little more time. So if I were to do this, what I do is I would list the, now obviously that's good for a large number, that method. It might make your life easy, but when I do this for the square root of 80, I would like to list all the factors quickly for 80. So as we know, the factors of 80 are 1, 2, 4, 5, 6 doesn't work, 7 doesn't work, 8, 10, 5 would be with 16, 4 would be with 20, 2 would be 40, and that would be 80. Some people would say, "Oh, this is harder for me." Well, that's why we have different methods, right? And we show a couple ways to work this through. And then what I do is look for the greatest perfect square factor, which would be 16, right? So when I do that, I can say that the square root of 80 is equal to the square root of 5 multiplied by 16. Right? And then I'm going to write it in the reverse order. Not that it makes a difference, but I like to put the perfect square first and then the second factor second. So we know that 16 times 5 is 80. We did those factors. 16 was the largest perfect square. So then we split this into two radicals. So we have, that's equal to the square root of 16 multiplied by, then we split them into two radicals, the square root of 16 multiplied by the square root of 5, and we know that the square root of 16 is equal to 4, so then it becomes 4 root 5. I find that easier. That's just me. You can use whatever method of your choice, like I mentioned, but that's a method I like to use for that. Again, you can do either method and it will work. So the next one, we can do the same thing. We can list the perfect cubes of 144, or we can do the method that we show the perfect, like prime factorization. But I'm just going to list the factors. So on a piece of scrap paper, I would go and list the factors. So I'll do that right here quickly. 144, and that would be 1 and 144, right? And then after that would be 2 and 72. And then we'd have 3. Uh, 3 and 48. Again, I'm just doing this on scrap paper. Like, you can see me write that. Then 4 and 36. Alright, so 5 doesn't work, obviously. 6 and 24. 7 doesn't work. 8. And 18. Right, so you're listing all the factors. This is just another method. Keep going. 9 and 16. 10 doesn't work, 11 doesn't work, and then it's just 12 and 12 is the last one, right? So there's all your factors. And what you want to do is you want to find the one that has the greatest perfect cube. So you're looking at these, make these a little smaller, just smaller one line here. So 8 is actually the only perfect cube, right? So 8's the only one that's really going to work. 8 and 18, right? Because 8 times 18. So that's what I would do here with the cube root. I would list it as that's equal to the cube root of 8 times 18. So I'm going to get rid of this because this was just my scrap paper, right? We're listing the factors, which you guys know how to do. Okay. And then I'm going to copy this, break it apart. Break it apart into 2 cube roots. Alright, so then this becomes, and you can put a multiplication symbol in the middle if you want there. Doesn't hurt. So we break them up into 2 cube roots. We know the cube root of 8 is 2. And then the cube root of 18 is the rest. So these are called mixed radicals because they have a coefficient and they still have some radical there. Okay, so they're equivalent, and again you can check them on a calculator to make sure they're the same, right? And then the fourth root of 162, the factors of 162 be 1 and 162, 2 and 81. Boom, you got it. 81 is a perfect fourth root. Okay, so you can take the fourth root of 81, it's 3. We did that earlier today. So that can be written as 81 times 2, right? Okay. Again, this one was, we got lucky because it gave us the, in our second factor, right? We didn't have to list them. As soon as you get to 1, you don't need to go any further. So we split this into 2 radicals. Oops, sorry. So the fourth root of 81 multiplied by fourth root of 2. Okay. Which is equal to fourth root of 81, as we know, is equal to 3. We did that earlier. So it becomes 3 times fourth root of 2. All right. And again, you can use the prime factorization method. I'm not going to. I'm doing this like I showed at the bottom here, using the factors of your number. There's some check your understanding question. There's the answers there. You can do those as well. Give them a shot. That's it. All we have time for. So we'll come back and we'll do example 2 in the next video. All right. So hope everybody had a good experience with this. And if you have any questions at all, please let me know. Thank you.